Good afternoon, dear students. In the previous class, we had learnt about how to form a table, and we have learnt about the general format of the table, which we have learnt also how to form the blank table, what the data was given, and to exhibit the blank table. Now, in today's class, we were moving on to the fourth chapter, that is diagrammatic and graphical representation of the data. In previous class we had learned how to represent the data in tabular form. In this chapter we will learn how to express the data, that is tabulated data, in the form of diagrams and in the form of graphs. To make the data easy to understand, even at a glance, diagrams and graphs are used. So one diagram is enough to represent a given data more effectively than the thousand of words. So we will see what is the importance and need of the data. Diagrams and graphs are extremely useful because of following reasons. Some of the reasons are to be considered for the usage of the diagrams and the graph. First one, they are very attractive, and hence diagrams and graphs are commonly used in newspapers and magazines for the purpose of advertisements and campaign. The first need or the first importance is they are very attractive. So the diagrams and the graphs are commonly used in newspapers and magazines for the purpose of advertisements and campaigns. Second one, they give bird's eye view of entire data at a glance. Whenever we see the graph, we can understand what the data is of. So it gives a bird's eye view of the entire data at a glance. Third one, they can be easily understood by a common man. It is very easy to understand, so a common man also can understand it at a glance. Next, fourth one, they can be remembered for a longer period of time. Whatever the diagram or whatever the picture is being seen at once, it can be remembered for the longer time. And last one, fifth one, they facilitate comparison. It is very easy to compare the data. Next we shall see the general rules for construction of diagrams and graphs. General rules for constructing diagrams and graphs. The first rule is every diagram should have suitable title and is written above it. Every diagram should have a suitable title. Title means whatever the data is represents, we need to mention it at the top as a title. Next, second one, it should be neat and attractive. So whatever the diagram is being drawn, it should be very neat and attractive. If it is neat, then only we can understand, we can get the clear idea what does the data represent. Next, proper scale according to the size of the paper should be selected. Proper scale. Whenever we draw the graph, we take the scale in terms of x-axis and y-axis. We see the length of the paper, and we divide the axis into certain values. Then that is nothing but the proper scale we are using according to the size of the paper. Next, third one, it should be fourth one, it should not be overloaded with more information. It should not be overloaded with the more information. Whatever the necessary data has been there, that only must be entered in the diagram or the graph. Other unnecessary data should be excluded from this. Next, fifth one, to indicate different parts, suitable shades, colors and crossings should be used. Whenever in a particular graph or the diagram many datas are been there, so different data should be marked with the different shades or the colors. Sixth one, an index indicating different shades, color, crossings, etc. used should be shown clearly. In a graph, a particular index must be shown so that what index, which shade represents the different data. Next, seventh one, it should be complete in all respects. It should be complete. Whatever the data is been given, the graph should consist of that particular data completely. Next, eighth one, it should be simple and self-explanatory. Whenever the data has been there, do not make it much complicated. It should be very simple and it should be self-explanatory. So these are the 8 rules which are used for the construction of diagrams and graphs. Next we move on to the types of diagrams. There are 4 types of diagrams. That is, first one dimensional diagram, second one two dimensional diagrams, third one three dimensional diagrams, fourth one pictograms and cartograms. So these are the 4 types of the diagrams. In your syllabus, we will be discussing only one dimensional and two dimensional diagram. In your syllabus, we will be learning only one diagram, one dimensional and two dimensional diagrams. So next we move on to the first one, that is one dimensional diagram. The diagrams drawn by considering only one dimension are called one dimensional diagram. The diagrams drawn by considering only one dimension are called one dimensional diagrams. They are mostly the bar diagrams where only height or length of the bars is considered. You might have learnt about the bar diagrams in your previous classes. Bar diagrams has the height, or we mean it has a length. Only one dimension is been considered. So some of the types of the bar diagrams: first one simple bar diagram, second one multiple bar diagram, third one component or subdivided bar diagram, fourth one percentage bar diagram. So under one dimensional, what does one dimensional mean? It means that considering only one dimension, the diagrams drawn by considering only one dimension. And in one dimensional diagram there are 4 types. They are simple bar diagram, second one multiple bar diagram, third one component or subdivided bar diagram, and fourth one percentage bar diagram. Now we shall learn in brief what are these. First one, simple bar diagram. Simple bar diagram is to represent the data rectangular bars of equal width and height proportional to the magnitude of the items and drawn with proper scale. So bar diagrams are represented by the data is been represented in rectangular bars of equal width and height. The width should be equal. It should be with equal width and height proportional to the magnitude of the items drawn with the proper scale. Width of the bars is taken merely for attraction, but it is nothing to do with the data. It is used for comparative purpose, study of 2 or more items of a single variable. We can compare it with 2 or more items of single variable. For example, the figures of imports, exports and population etc. for few years are represented to be by the simple bars. Next we shall understand this simple bar diagram with an example. Example: following figures represent the decadal change of population of India. Draw a simple bar diagram. They have given the decadal change of population. Every 10 years the change of population is been mentioned, so you have to represent it by the simple bar diagram. Years in 1901, 238 million population. In 1911, 252 million population. 1921, 251. 1931, 278. 1941, 318. 1951, 361, and so on up to 2011, 1210 million. So now we have to represent this in the simple bar diagram. So you have to take a graph sheet. In a graph sheet, for the timing you can draw it in your book itself. Draw the x-axis as well as the y-axis. On x-axis take the decadal years, and in y-axis take the population in millions. So you need to take a particular scale. Before to that you should go through the rules of the diagrams and graphs. So before you could draw, you should know the rules of the diagrams and graphs. First you have to mention the title of it. What does the title represent? It is simple bars representing the population of India from 1921 to 2011. In the solution part it is mentioned. So first, before you need to mention the title. Next you have to take the proper scale. Y-axis you can take 1 centimeter has a 10 years, then you can continue so on. So it is 1901, next is 1911, so on you can consider. Next in y-axis, same way, consider 1 centimeter has a 200 millions, then plot the graph. So you can get the graph as shown in the next. Second one, we move on to the multiple or compound bar diagram. Multiple bar diagrams are used to represent various sets of interlinked data. Multiple bar diagrams are used to represent various sets of interlinked data. A set of adjacent bars. Adjacent bars means one beside the other, is drawn for comparison. Bars are differentiated with shades or colors, and an index is provided for easy reference. So you'll come to know in the solution there is an example where you can understand. So what is multiple bar diagram mean? Multiple bar diagrams are used to represent various sets of interlinked data. So many data you can represent in a multiple bar diagram by drawing the adjacent bars for comparison. Next we shall move on to the example. Example 1. Following is the data showing food grain production in different years. Draw a multiple bar diagram to represent the data. Food grains of different year it is been given, that is 2008, 2009 and 2010. Food grains are rice, ragi and wheat. So you need to take different shades for food grains, that is rice, ragi and wheat. So go to the solution part. Multiple bar diagram represent the food grain production for 3 different years. In 2008, rice, ragi and wheat. In 2009, rice, ragi and wheat. In 2010, rice, ragi and wheat. So take the scale. In x-axis you are unable to mention the scale, so go for y-axis. 1 centimeter represent 50 tons. 1 centimeter represent 50 tons. So in 2008 the production of rice and ragi and wheat. mentioned with the different shades, and the shades are being indicated in the side. You can see within the graph, that is rice, ragi and wheat. With a small box it is been indicated, so it is nothing but the index form for the easy reference. It is shown in the index form for the easy reference. Next, moving on to the component or subdivided bar diagram. Simple bars are drawn for the total magnitude of variables. Further, the bars are divided into various segments, each segment representing a given component of total. To distinguish between the various components, different shades or colors are used. For easy reference of components, an index is provided. These are useful in comparing the total magnitude along with the components. So for the better understanding, we will move on to the example. Example 1. For the following data regarding the expenditure of families A and B, represent the data by subdivided bar diagram. Items and expenditures in rupees of family A and family B, it has been given. Food, clothing, house rent, education, fuel, others, etc. you need to mention. First you total them, you see what is the total of family A and family B requirement. First you total, then you subdivide them into various segments. We'll see the diagram. First solution, that is subdivided bar diagram representing the expenditure of family A and family B. See how it has been represented. First, the family A total, it has been nearly 8,000, and of family B total, it has been near to 12,000, that is 11,000 something total it should be there. See how they have been plotted. First they have marked food that represent 2,580 of family A. Above that 880 total, so 2,580 plus 880. Then above 880 plus 2,200 will give you house rent. After that, above house rent, it is education 360 plus fuel plus others, it will be total nearly to 8,000. Similarly for family B, in say likewise, you can divide them into the various segments and mention them in the index form. Last one, percentage bar diagram. This is another form of the component bar diagram. In this, the components are not the actual values but percentages of the wholes. So whatever the value is being given, we are going to convert it in the percentage. Bars are drawn with the height equal to 100 each, and bars are divided into segments according to their values expressed as percentage of the respective total. Thus, different subdivisions are shaded properly, and the index is provided for easy reference of the component. So these have been useful in comparing the percentage components. So the percentage of an individual component is been calculated, which is equal to individual value divided by the total value into 100. Individual value divided by the total value into 100. The percentage has been calculated. We'll move on to the example to understand that. Example, following is the marks obtained by the total student A and B in the annual examination. Represent the data by percentage bar diagram. Subjects are given Kannada, English, Statistics, Economics, Business, Accountancy, and the total is 526 of student A and 544 of student B. First you have to convert marks into percentages, that is percentage of a subject, it will be equal to individual value divided by the total value into 100. You calculate separately for student A Kannada and student B Kannada. Separately you need to calculate. Here they have given just an example, that is Kannada how they have been calculated, and for student B statistics similarly other values we need to calculate. So make a tabular column representing first, that is subject, next student A, his individual marks and in percentage, then you need to take the cumulative percentage. Cumulative percentage you have done in your SSLC how to calculate cumulative value. Similarly you have to do it here. Next, student B, marks, percentage and its cumulative percentage. Cumulative percentage you have to take. Then draw the percentage bar diagram showing the marks of student A and student B. Student A and student B. Then as you have done in the component bar diagram, similarly you can do it here. So in total you need to get the 100% by total dividing all 6 subjects. So the 6 subjects are divided or shaded and it is been represented in the index form. Thank you.